Example 3 has a system with multiple standard forms. We're going to use this example to remind us of the two times where an inequality symbol can flip. So there are times when your symbol will switch directions. The first time is when your inequality is not written in proper form. For example, let's say you had 2x plus 3 is less than or equal to y. Because your y variable is not at the front, you would have to mirror the equation. And then when that would happen, you would also have to flip the symbol to make sure it is keeping the value that it's supposed to. The other option is when you're actually solving for y. If at any point you multiply or divide by a negative number, that will cause your inequality symbol to flip as well. So let's start with the first equation, which is a standard form, and let's convert it like we've been practicing. Okay, from there we'll subtract our 2x from both sides, and then we'll divide by 5. Because we're dividing by a positive, our inequality symbol will stay facing the same, and then we continue like normal. So negative 2 divided by 5 would be a fraction, negative 2/5, and then 15 divided by 5 would become a 3. And so let's go ahead and graph our slope-intercept form. It does not have an equal to, so this is going to be a dashed line with a y-intercept at positive 3 and a slope of down 2 over 5 as far as you can go, and then you reverse it up 2 and to the left 5. And then when we connect, it is going to be dashes. And then our shading, because it's a less than, we're going to be shading below. All right, our second equation is a special case. That is a box, a vertical line, also dashed. There is no equal to. When x is 0, we're there at the origin, and then we're going to do vertical dashes, make them nice and thick so it stands out on top of that y-axis. And then make sure that they actually look like dashes and not are blending in to look like a solid line. Your symbol for that is a greater than, so we will be shading to the right. As of right now, we are mixing down here in this quad shape, but we do have one more linear to go. And our last one is in standard form. So again, we have to convert to slope-intercept form. Subtract your x, and then divide by the coefficient. So because we are dividing by a negative 2, we are going to flip that inequality from a less than equal to greater than or equal to, and then divide like normal. Take your negative 1, divide by negative 2, that gives you a positive 1 over 2, and 8 divided by negative 2 is negative 4. So we'll graph our slope-intercept form. It is an equal to, so it will be solid. It does have a y-intercept at negative 4, a slope of 1 to the right 2 as far as you can go. Reverse that direction, down 1, left 2, until you hit the edge. We said equal to is a solid line, and then it is now a greater than symbol, which means we are shading above. So our colors are mixing in this little triangular section. All right, so let's see which order pairs are solutions. And let's start with the first one, 0, negative 4 would be down there, and that is going to be a maybe. It is on a solid line and not necessarily in the shaded, so we're going to check that. We've got 3, negative 1, that is in our final shaded, so that is a solution. We have 0, positive 3, that's dashes, that's a no. And then negative 4 Positive 2 would be in the white, not in the shaded, so that's a no. So we're going to practice using substitution into all three of those inequalities using the original forms, just in case you make a mistake somewhere along the way. Always go to the originals. And let's check our ordered pair with an x0 and a y -4. So plugging in 0 for x and -4 for y, we will simplify that left side, either doing it in your head or typing in your calculator. 2 times 0 is 0. 5 times -4 is -20. So 0 plus -20 is -20. And then we'll drop down that less than and the 15. And then that is going to be a true statement because negatives are smaller than positives. All right, plugging in our x value of 0, 0 greater than 0, that's a no because it's equal to. And then practicing our substitution where you have to actually set it up yourself. We have an x that is 0. We have a y that is -4. When we simplify that left side, we get an 8. 8 is less than or equal to 8. That is true. But because we have one false statement, that is going to make this not a solution. So we're going to say, oops, my little space got deleted. 0, -4 is not a solution because not all inequalities have a verified solution, meaning they are not all true.